Hello, everybody. Welcome to the review for the first test on exponents. The directions say show all of your work and box in your final answer. So this first section, we're just matching, and we are going from radical form to exponent form. These are called rational exponents because they're fractional. So the form that we're following is the nth root of x to the m power. Well, let me do that in color. So the nth root of x to the m power is the same thing, is equivalent to x to the m, divided by n power. So you can see that the exponent becomes your numerator and your index becomes your denominator. So if we look, we're looking for a 3 in the numerator and we are looking for a 7 in the denominator. That's what we're looking for over here. So 3 in the numerator and the 7 is in the denominator. So that would be B. Here we're doing the opposite. We're looking for a 7 in the numerator and a 3 in the denominator. So that would be C. In number 3, we have a 2 in the numerator and we have a 9 in the denominator. So 2 in the numerator, 9 in the denominator, that's going to be A. And then last one's a little bit tricky because you don't see what the index is. But when we don't see anything written here, we assume it's a square root. And we assume that that's a 2. So we're looking for a 2 in the denominator and a 9 in our numerator. So numerator of 9, denominator of 2 would be D. Okay, next section. So simplify 25 f to the negative second power, g to the second power, divided by 5 f to the first power, g to the negative third power. Simplify that completely, reduce all fractions, don't leave any negative exponents in your answer. Okay, so when we have a negative exponent in the numerator, we're going to bring that down into the denominator. So I have an f to the first power in the denominator already, and I'm going to bring this f to the negative 2 down to the denominator and make it positive. I'm going to do the same exact thing with this g to the negative third power in the denominator. I'm going to bring that up, and I'm going to make that positive. Now, it really doesn't matter where I put it. I could have squeezed it in here, put it over here. It doesn't matter because I'm going to simplify. My coefficients are just going to simplify like normal. 25 divided by 5 is 5. Then here I'm going to add my exponents. That's the rule when I'm multiplying bases. I add exponents. Same here. 1 plus 2 is 3. So why does that work? Well, if I have g to the second power, and then I have g to the third power, I meant to make that purple. So g to the second power, g to the third power, if I count them up, that gives me 5 g's. Said to box in my answer. Okay. Kind of the same deal going on here. I just don't have any negative exponents, and I have parentheses with a power on the outside. So what that means is I'm going to take this entire quantity, this entire parentheses, and I'm going to multiply it by itself 3 times. So I have 3bn, 3bn, 3bn. 3 times 3 times 3 is 27. BBB and NN. Same thing's going to happen over here. I have negative 4 BBB, NN, and I have to do that twice because of my second power right here. That's an N. So times negative 4. Oh my goodness, my writing is so sloppy. times -4, B, and N. Is that 5? 1, 2, 3, 4, 5. Okay. So -4 times -4 is 16. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Now for my final answer, remember those two things were multiplied by each other. So I'm going to use my calculator here for 27 times 16. 432. 3 B's, 10 B's, so that's 13 B's. And 3 and 4 gives me 7. Remember, a negative times another negative is positive. The shortcut for this one is to multiply our exponents. So remember, these are both ones. So 1 times 3 is 3. 1 times 3 is 3. 5 times 2 is 10. And then 2 times 2 is 4. Oops. Okay, fill in the blanks to simplify this completely. Oh, it looks like we should have a blank up here. Or maybe not. I guess we'll just fill in the blanks and see how it goes. All right, so 4 times 3 is 12. That's where that came from. So 5 plus 3 would then be 8. 2 times 2 is 4. And then we don't have any t's here, 4 t's there. So that stays a 4. Now what do? We divide these. So 12 divided by 4 is 3. And then we have 8 t's in the numerator. 1, 2, 3, 4, 5, 6, 7, 8. 4 t's in the denominator. And then we get to cancel because we're dividing. T divided by t is 1. 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 So we're left with 4 t's in the numerator. So my final answer is 3t to the 4th power. What is the value of the variable m so that the whole expression is equal to 1? So what power can I raise this entire quantity to that it would just give me 1? That would be 0. Anything to the 0 power is equal to 1. Now you got to be careful though. So it's not just that you see a 0 and the whole entire thing is 1. If it looked like this, only that part would be 1. And we would say that would be 5 times 1 times y to the 3rd power, or 5 times y to the 3rd power. So you got to be careful. But since this entire thing is in parentheses, raised to the m power, that's why this is all equal to 1. Okay, number 9. We saw something like this on our scavenger hunt. So and also on that word bank, not in word bank, it was a number bank activity we did the day before we took the quiz last week. So we have b squared. There we go. Then we have b to the 5th. And we want to get 12 b's total. So how many are we missing? Well, if we had another set of b's, another set of these, another set of 5, we would have 12, right? Because that's 5, 10, 11, 12. So since we need 2 sets of b to the 5th power, that exponent's going to be a 2. So use your rule. 5 times 2 is 10, plus 2 is 12. Okay, that's all for this video. You need to go to video 2 for the rest of the problems.